Okay, so we're going to go over the warm-up real quick, and this should be pretty quick. In part A, you're looking at an equation m y equals mx plus b. We know that m is the slope, and we know that b is the y-intercept. So our slope is going to match up with the m. So our slope is 2/3. Our y-intercept matches with the b, and in this case, our b is -6, or our y-intercept is 0, -6. Now we have to graph it. So when you graph, don't forget that you're going to start on the y-intercept. Your y-intercept is 0, -6, and that's on the y-axis. And the slope is 2/3, so we're going to go up 2, right 3, up 2, right 3, and then maybe down 2, left 3. And we're going to use a straight edge to connect. I have an index card. You want to use a straight edge because especially like when you do systems, you want to make sure you're getting that point of intersection in the correct spot. So you definitely want something that's straight. And then label the y-intercept A. So we're going to be using this in a little bit. So the y-intercept, we're going to put an A right here because that represents that guy. And the next thing we're going to do is we're going to go through and do part B, and that is to find the x-intercept and y-intercept and graph the equation. When you're doing intercept form, one of the cool things about that method is that you can just, to solve for the x-intercept, you can just, if it's in standard form, take your x term and set it equal to your constant and solve for x. So you can do that, and that's much quicker. That's an option. That's like a way you can do it. And then our x-intercept obviously starts with the x-coordinate and ends in 0. For the y-intercept, you could do the same exact thing. You could take the y component and set it equal to the constant, and then solve for y, in which case you would get y equals 2. Remember that this is the y-coordinate, so you want the x-coordinate to be 0. So if I was going to graph using intercepts, I would only have to plot those 2 points. So I'm going to go to 3, 0, which is on the x-axis. It's an x-intercept. Y-intercept is 0, 2. I'm going to take my straight edge, and I'm going to see right away that there is going to be a point of intersection. Move a little bit closer. Right here. Boom. Now it says label the y-intercept B. So here's my y-intercept, and that is B. In part C, it says the common solution, and that is actually the point of intersection. And our point of intersection for this graph is going to be x comma y. We always write that as a coordinate. And the x-coordinate is 6, and the y-coordinate is -2. That is the solution, 6, -2. And what they want us to do is name this point C. So I'm going to put a C right here. Now they want us to do the midpoint of AB. So in order for us to do midpoint, we're going to have to use the midpoint formula. So our midpoint formula, if you remember from last lesson, is your x's added up and divide by 2, and your y's added up and divide by 2. Remember, this is a coordinate. So my coordinate for A is 0, -6. And my coordinate for B is 0, 2. And what we're going to do is we're going to plug these in. Now this is going to be super easy because 0 plus 0 over 2 is going to give me 0. And this is 2 plus -6 over 2. And that's -4 over 2. And that's going to give me -2. So my midpoint is 0, -2. Let's check this out. There's the midpoint. And I guess I'll call that M. Okay. Now, the next thing that we want to do is we want to, there it is. The next thing that we want to do is we want to figure out what kind of triangle ABC is and justify it. Now, you can't just look at it and tell what kind it is. You have to actually do some math to justify it. So what we're going to do is take a look and see, just eyeball what kind we think it is, and then we can test from there. So I'm looking at this, and the only way to really classify a triangle is two ways. You can either classify it by sides or you can classify it by angles. Since I don't have the angles or a protractor in this case, what I'm going to want to do is use the sides to determine what kind of triangle it is. So what we are looking at here is maybe equilateral. I'm not sure. They could be equal, or it could be isosceles, or they could be off just by a little bit, and it could be scalene. So the only way to determine that would be to use distance formula. So to do part C number 11, you want to do the distance of AB, which is easy because it's a vertical line. So all you have to do is count the boxes. That's not a hard one at all. So we're going to look at distance of AB. You can count the boxes, and to go from -6 to +2, that's 8 boxes. So that distance is 8 units. Okay. Now, if it's equilateral, then what that means is that from B to C and from A to C are also going to turn out to be 8 when we're done. And that's how we're going to figure it out. So the next step is we're going to look at the distance formula. Remember our distance formula from last lesson was y2 minus y1 squared plus x2 minus x1 squared. And don't forget the big square root there. So there's my formula that I'm going to use, and I have to do that on BC, and I have to do that on AC. Okay? So B's coordinate is, I'm going to do BC. B's coordinate is 0, 2. And C's coordinate is 6, -2. And we're going to see if this is actually going to be equal to 8 when we're done. So let's plug into our formula and see what we get. Y2 minus y1 is -2 minus, -2 minus 2 squared. And x2 minus x1 is 6 minus 0 squared. -2 minus 2 is -4. And -4 squared is 16. 6 minus 0 is 6, and 6 squared is 36. 16 and 36 is 52. So the square root of 52 is not 8. The square root of 64 is 8. So it's a little bit smaller than our AB. Okay, so right now it's not equilateral. We have one more classification or one more distance to do before we can classify. And so what we need to do now is we need to see what AC is going to be. A's coordinate is 0, -6. And C's coordinate is still 6, -2. One more distance. Y2 minus Y1, that's -2. God, I did it again. -2 minus -6 squared. And x2 minus x1, 6 minus 0 squared. Let's check this out. This is -2 minus -6. Now a minus and negative is going to become a positive. So this is really -2 plus 6, and that's 4. And 4 squared is 16. And 6 minus 0 is 6, and 6 squared is 36. Look, this is just like the other one. You get the square root of 52. So what this outcome means, and this is what we use to defend our answer of how we can classify the triangle. Our distances are these three things. We've got 8, we've got square root of 52, and we've got square root of 52. So if I had to classify this triangle, I would say that two sides are equal in length. If two sides are equal in length, that makes it isosceles. And there's the work to prove it. Part D, really quick. I love these questions because they're super fast as long as you know what you're doing. The graph of the equation x equals -4. So this equation starts with x equals, which means that it's passing only through the x-axis. It's passing through the x-axis. So what that looks like is this. If here's my graph, and here's the xy axis, and I'm only passing through the x-axis. The only way that I can do this at -4 is to have this kind of line. This is x equals -4. It only passes through the x-axis at -4. So this kind of line is vertical. Vertical lines always start with x equals and end in a constant. Okay? I'm going to make this a solid line because it's not dashed. I just wanted you to be able to see it. And then the slope of a vertical line, well, you know that vertical lines have a rise, but they don't have a run. So our rise can be as tall as we want, but if it's anything over 0 or no run, then that means that our line has an undefined slope. Vertical lines have undefined slopes. Okay?